Windfarm is a groundbreaking project that demonstrates how renewable energy can be used to power offshore oil and gas operations. In this section, we will explain how a floating offshore wind farm called Windfarm is already powering two existing oil and gas platforms in the North Sea, reducing their natural gas consumption and emissions by 35%. Windfarm is located about 140 kilometers off the coast of Norway, in water depths between 260 and 300 meters. It consists of 11 wind turbines, each with a capacity of 8.6 megawatts, MW, mounted on floating concrete structures that are anchored to the seabed. The wind turbines are connected by a 2.5-kilometer-long network of cables that can transmit up to 66 kilovolts of electricity. The wind farm is designed to supply electricity to the Snorre and Gullfaks oil and gas fields, which are operated by Equinor and its partners. These fields have been producing oil and gas since the 1980s and 1990s, respectively, and have a combined production capacity of about 250,000 barrels of oil equivalent per day. However, they also rely on gas turbines to generate power for their operations, which results in significant carbon dioxide, CO2, and nitrogen oxide, NOx, emissions. By using electricity from Windfarm instead of gas turbines, the Snorre and Gullfaks platforms can reduce their natural gas consumption by about 35%, saving about 200,000 tons of CO2 and 1,000 tons of NOx emissions per year. This is equivalent to the annual emissions from about 100,000 cars. The wind farm can also provide a more stable and reliable power supply for the platforms, especially during periods of high wind speed. Windfarm is not only a solution for reducing emissions from existing oil and gas fields, but also a test bed for developing and scaling up floating offshore wind technology. Floating wind farms have several advantages over fixed-bottom wind farms, such as being able to access deeper waters with higher wind speeds, having lower installation costs and environmental impacts, and being easier to decommission. However, they also face technical challenges such as coping with harsh weather conditions, ensuring stability and safety, and optimizing performance and maintenance. Windfarm builds on the experience and expertise gained from previous floating wind projects such as Hywind Scotland, which was the world's first commercial floating wind farm when it started operating. In Windfarm will be the world's largest floating wind farm when it is fully operational in 2023, with a total system capacity of 88 megawatts. It will also be the first floating wind farm to use new and larger turbines, simplified moorings, concrete substructures, and integration systems between gas and wind power generation. Windfarm is a pioneering project that showcases how offshore wind can play a key role in the energy transition and the decarbonization of the oil and gas sector. It is supported by public funding from Enova and the business sector's NOx fund, as well as by private investment from Equinor and its partners. It is expected to create new industrial opportunities for Norway and its supplier industry in a growing global offshore wind market. One of the challenges of the energy transition is how to use the existing infrastructure of the fossil fuel industry for renewable energy sources. One possible solution is to convert abandoned oil and gas platforms into production and storage units for hydrogen and synthetic gas. These gases can be used as clean fuels for various sectors, such as transportation, industry, and power generation. Hydrogen and synthetic gas are produced by converting electricity from offshore wind farms into chemical energy. This can be done by using different processes, such as electrolysis, autothermal reforming, or gasification. Electrolysis splits water into hydrogen and oxygen using electricity. Autothermal reforming reacts natural gas with steam and oxygen to produce hydrogen and carbon dioxide. Gasification converts solid fuels, such as coal or biomass, into a synthesis gas that contains hydrogen, carbon monoxide, and other components. The advantage of these processes is that they can use the existing pipelines and platforms of the oil and gas industry to transport and store the gases. The platforms can also be equipped with carbon capture and storage technology to reduce the emissions of carbon dioxide from the production of hydrogen and synthetic gas. This way, the platforms can become hubs for green gas production and distribution in the North Sea. Converting oil and gas platforms into hydrogen and synthetic gas units could create a new market for green gas in the region. It could also help to balance the intermittent supply of wind power by storing excess electricity in the form of chemical energy. Moreover, it could extend the lifespan of the platforms and avoid the costs and environmental impacts of decommissioning them. Several studies and projects have explored the feasibility and potential of this idea. For example, a study by the Dutch Energy Delta Institute found that abandoned oil and gas platforms in the North Sea can be profitably converted into production and storage units that convert electricity from offshore wind farms into hydrogen and synthetic gas. The study also identified a niche market for green gas in the chemical industry or the transportation sector. Another example is the Zero Carbon Humber Alliance, which aims to decarbonize an industrial region in the UK by using hydrogen and carbon capture and storage. One of the projects within this alliance is Hydrogen to Humber, H2H, Saltend, which plans to build a 600 MW autothermal reformer with carbon capture to extract hydrogen from natural gas on an existing platform. These examples show that converting oil and gas platforms into hydrogen and synthetic gas units could be a viable way to use the existing infrastructure of the fossil fuel industry for renewable energy sources. This could create a green gas network in the North Sea that could support the energy transition and reduce greenhouse gas emissions.